In this lesson, we're going to have our first introduction to what are called logarithms. So what is a logarithm anyway? It's a question often asked, and what we're going to try to answer in this video. What is a logarithm? Well, here's what we want to understand a logarithm as. We want to understand a logarithm as nothing more than an exponential statement written in a different form. Okay, so a logarithm is nothing more than an exponential statement written in a different form. We remember that exponential statements are statements like 3 to the 4th or 6 squared. An exponential statement. So as an example, I've got 4 different what we call logarithms here that are simply exponential statements written in a different form. The question is, we have to figure out what form and how are they written, and how can we evaluate and, or in this case, simplify them. So the piece that indicates that we're dealing with a logarithm is this log. Log is short for logarithm. And there's 2 elements to a logarithm. The first element is what we call the base value. Okay, so the log indicates that it's a logarithm. The second element right here is the base value. Okay? And then this last element here is the piece associated with the logarithm. Okay, so again, we have the log indicating it's a logarithm. We have our base value, and then we have the element connected to the logarithm. Another way to think about it is it's what's inside the logarithm. So the question is, how is, and this is how we'd read this, log, I said 2 is the base value, so we would read this as log base 2 of 16. This next one here we would read as log base 4 of 64. This next one here we would read it as log base 3 of 243. It's important that we read them the right way. This last one here, you might notice that the base value is missing. Okay? Whenever the base value is missing, we call this a common logarithm. And the assumed base value is equal to 10. So this statement right here would be read as log base 10 of 1,000. So when the base value is missing, when there's no value there, it's the common logarithm of base 10. So log base 10 of 1,000 is how I would read that. So let's go back to this first one here that we read as log base 2 of 16. And ask ourselves what that looks like in the context of simply being an exponential statement in a different form. So log base 2 of 16 can be simplified to a smaller value. The question is, what is that value? And here's all you have to ask yourself. Take the base value of 2 and ask yourself 2 to what power is equal to 16. That's it. That's how it's related to an exponent. The base value of 2 raised to what power, we'll call that x, is equal to what is inside the logarithm, the 16. So we can start counting. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it takes 4 2's multiplied together to equal 16. So 2 to the power of 4 equals 16. What that means is this entire logarithm simply simplifies to 4, because 2 to the power of 4 is equal to 16. And that's it. That's its relation to an exponent. So let's take a look at this next one right here. I've got log base 4 of 64. So again, it's the base value, in this case it's a 4, raised to what power is equal to the piece in the logarithm, the 64. Well, let's count it off. 4 times 4 is 16, times another 4 is 64. So in this case, 4 to what power is equal to 64? Well, it looks like 4 to the third power is 64. So the log base 4 of 64 simply equals 3. This whole piece can be simplified to 3. Let's look at this next one real quick. Log base 3 of 243. So again, we ask ourselves the question, 3 to what power is equal to 243? Well, 3 times 3 is 9, times another 3 is 27, times another 3 is 81, and then if you do this in your calculator times another 3, you'll find that it equals 243. So x to what power is 243? It looks like I have 5 3's multiplied together. So the log base 3 of 243 is equal to 5 because 3 to the 5th is equal to 243. Lastly here, we have the log of 1,000. Now remember, common log has a base value of 10. So the log base 10 of 1,000, we would ask ourselves, 10 to what power is equal to 1,000? Well, 10 times 10 is 100, times another 10 is equal to 1,000. So it took 3 10's multiplied together to get to 1,000. So the log base 10 of 1,000 is 3. Now that we've seen how to evaluate a logarithm and to determine what it equals, let's add some to the examples, the last two examples we want to take a look at in this video, and see how we can take an expression that's more than just a logarithm, but there's other things going on as well, and simplify it. So here's how this works. Right here I have 4 times the log base 3 of 27, all divided by 24. Here's what I'm going to do. I'm going to go 4 times what? Well, log base 3 of 27. In order to simplify that to a single number, what do we have to ask? The base value of 3 raised to what power is equal to 27? Well, 3 times 3 is 9, times another 3 is 27. It took 3 3's, so 3 to the third power is equal to 27. So this entire piece right here can simply be replaced with a 3, because the log base 3 of 27 is 3. So I've got 4 times 3 all over 24. 4 times 3 is 12 all over 24. Simply reduces to 1/2. So this whole statement up here of 4 times the log base 3 of 27 all over 24 is equal to 1/2. Notice what I did? I looked at the logarithmic statement and I simplified it to a single number before I did anything else. That's the key. We want to take any and all logarithmic statements, simplify them to a number, and then simplify the rest of the expression. Let's look at this one last example right here. I've got -6 times the log base 2 of 32, all divided by the log of 100. So I've got -6 times, well, what does the log base 2 of 32 equal? Well, 2, my base value, raised to what power equals 32? Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. So it took 5 2's to get to 32. So 2 to the 5th power is 32. So the log base 2 of 32 can be replaced with a 5. So -6 times 5, all divided by, what is the log of 100? Well, when there's no base value, don't forget, that's a 10. So our base value of 10 raised to what power is equal to, in this case, 100? Well, as we know, 10 times 10 is equal to 100. So it's 10 squared that equals 100. Therefore, the log base 10 of 100 can be replaced with 2. Finishing this off, negative 6 times 5 is negative 30 all over 2, which simply reduces to negative 15.